Welcome back to part 2, equivalent forms of a number. So in our last little session, we talked about how numbers can be written in different forms, but still have the same value and sign. And we looked specifically at how fractions can have the same value and sign in their decimal form. So I want to notice something about all of these fractions. So these ones worked out really nicely. This one was a little long, but overall they worked out pretty nicely. And the reason why I say that is because when I went through this, all of these numbers, all of these fractions were equivalent to terminating decimals. Terminating decimals are decimals that end. They stop. They do not go on forever, and we like them because they do not go on forever. So sometimes some fractions will become terminating decimals when you put them into decimal form. So these are the ones that stop. They end. They don't go on forever. We like that. But other fractions will not terminate or end. And so we're going to see what happens, and we'll fill in this blank in just a second. So we're going to look at a few more fractions here. So here we have 2/3. So 2/3 is a fraction. It has an equivalent decimal. And we're going to do the same thing to figure out what the equivalent decimal is, but we'll notice something weird is happening. So to review, to find the decimal version of a fraction, we use division, because that fraction line is telling us to divide. It's telling us to divide by 3. So I'll go and I'll set up my 2 divided by 3 in my division problem. So there's 2 on the inside and 3 on the outside. Okay, set it up. 3 goes into 2. No, it doesn't. Put a 0. 0 times. Add my decimal points, add my next place. 3 does go into 20 though. It goes in 6 times. So 3 times 6 is 18. I will subtract and I'll be left with 2. Okay, I'll bring down my next place and I'll ask myself, 3 goes into 20. I just did this 6 times. And I'll say 3 times 6 is 18, and I'll subtract it off and I'll get a 2. And then I'll bring down my 0, and then I'll be like, okay, I've been here before. I think I could keep figuring out that 3 goes into 20 6 times, and I will never stop. This process will continue to go on forever, and I will keep just getting 6 out of every single time, and I'll never, ever, ever be able to be done. Okay, that's a little bit dramatic. I'll be able to be done because we know that this is what's called a repeating decimal. The place values, or all the values, are repeating each other. So I'm going to say, all right, repeating decimal. This process is going on too long. So I would say that 2/3 is equivalent to a decimal, but it's equivalent to the decimal. You could write 0.6666666 ... forever. One way to write it. A lot of symbols for me. So I would choose to write it in what's called bar notation, right? So I'd do 0.6, and because that 6 repeats, we draw the bar over it. So that's what I'd prefer to say that 2/3 is equivalent to. And we use bar notation to do so. Same value, they're worth the same. 2/3 is the same as 0.6 repeating. Same sign, we're good to go. Okay. So what we can say is other fractions result in repeating decimals when turned into decimal form. All right, let's do another one together. So this one's negative and it's a mixed number. Double whammy. So yesterday we talked about with negative numbers, when you turn a negative fraction or mixed number into its decimal form, your resulting decimal should be negative. So that makes sense, right? If it started negative, if it's an equivalent number, it also has to end up being negative. And the other thing we talked about with mixed numbers specifically is that you don't have to worry about the whole in this process, because if this is negative, if this has 3 wholes and 1/11 more, when I do my decimal, I'm still gonna have 3 wholes, so I'm gonna have 3 in front of that decimal point. And I just need to figure out what part is remaining. To do that, I'll look at my 1/11. Okay, 1/11. 1/11 is the division problem, 1 divided by 11. I can't see that, that's 11. I'm going to put that into its long division problem and see what happens as we repeat. Okay, 11 goes into 1, 0 times, add a decimal, add a place. 11 goes into 10, 0 times. I've already added my decimal, I'll just add a place. 11 goes into 100 9 times, because 11 times 9 is 99. And I'll subtract it off, and I'll get 1 left. I'll bring down my 0. And I'll ask myself, 11 goes into 10, 0 times. Bring down a decimal. Bring down a 0. 11 goes into 100, 99 times, 9 times, giving us 99. Subtract it off, I'm left with 1. This is looking familiar. I'll bring down a 0 just to make sure. Okay, I get 10. I've seen this fact before. It doesn't go in ever. Okay, and then I bring down a 0. Geez. 11 goes into 109 times. Okay, I think I'm getting the picture here. This is another repeating decimal. But this time I wasn't repeating the same multiplication fact every time. This time there were like 2 facts I had to remember. They were kind of a 2-step process. So this is still a repeating decimal because the process will repeat forever until I eventually gave up. So we know, we're going to say that 1/11 is equal to 0.09090909 ... But there's a better way to write this part. I'm going to look at what's repeating. So this one is repeating in 2 chunks. It's repeating 09, then 09, then 09, then 09. So if I were going to write that as a repeating decimal, I would write it as 0.09, and I would include that bar above both of those. So what does negative 3 and 1/11 equal? Well, it's equal to negative 3.09 repeating. I just added that little part in. Same sign, same value, still equivalent. Okay, you have 2 problems here, negative 5/9 and 2 5/6 that I want you to complete. Pause this video for a moment. Try to figure out the equivalent decimals for those fractions and then check back in. All right, you're back. For negative 5/9, you could have gotten any of these 3 answers. Negative 0.555 repeating, because that would still just be a bunch of 5s if we kept writing 555, 555, 555. Still a bunch of 5s. Or you could do it with 2. Sometimes people do that way, but here is probably the best way to write it. That negative 5/9 is the same as negative 5/9 is the same as negative 0.5 repeating. We have just 1 5 repeats. It's the most concise way to write it. Okay, next problem you are supposed to do is 2 5/6. This one was kind of interesting. When we divided, we saw that we got first out an 8, and then we saw we'd keep getting 3s forever. Right? It would look something like this. So when you go to write this in bar notation, you only want to include the bar over what is actually repeating. So the 8 is not repeating, the bar will not go over the 8, it'll just go over the 3. So that's what you should have gotten. Make sure you drop any questions or comments or something you learned in that next question, and I will see you very soon.